I just thought it would be nice, given that this was, a huge effort to get this out, to just kind of revisit, because yeah, it's definitely been a big milestone, and it's ended up being a big project that we worked on for a long time. But I think also everyone's really proud of what we put together, and kind of rightly so, because yeah, our ambitions kind of grew as this unfolded. And so, the original kind of motivation was to essentially establish Monty's capabilities, show that to the community, and kind of communicate that to others, and kind of what the current state of the art of a thousand brain system is. And of course, there's a variety of reasons we'd want to do that, but amongst other things, one of the main kind of aims of the TBP is to get people excited about and using thousand brain systems in this approach. And so, of course, showing what it's actually capable of is a big part of that, especially the academic community. But kind of along the way, I think it was just surprising how many kind of new things that came out. So new metrics, new understandings of what Monty's kind of actually capable of, that we hadn't, really conceptualized when we kind of first decided to write this. And also just lots of kind of fixes and general improvements to Monty's implementation, and many of those were definitely not trivial. And so it's been a huge team effort. Everyone at the Thousand Brains project, and also, like I said on Wednesday, a lot of the groundwork for this even started at Numenta. As Vivian was saying, although we've been working on the DMC paper for maybe 8 months, really this started more than 3 years ago, with the actual kind of initial work on the thousand on kind of Monty. But definitely special shout out to Scott and Hojay for the huge amount of effort they put into this. I think when you guys joined, the idea was this was going to be like a 2, maybe 3 month project that would be kind of a nice way of getting to familiar with Monty's experiments and how to run those and things like that. And so, thank you for all the effort you put in, despite it being actually a much bigger project we ended up doing. And so, yeah, kind of to rewind back to when we kind of started on this, what we had at the time was, of course, Monty, certainly a similar version to what we have now, but with some, as I said, kind of bugs and things like that we later discover. And we had some benchmarks kind of gauging approximately things like accuracy in the context of certain amounts of noise and things like that. And we had some kind of visualizations, but nothing particularly kind of glamorous. And so when we were kind of doing initial scoping work, I said it kind of started fairly simple, but then eventually grew quite a bit in ambition. And I'm not going to spend a long time on it, but just to kind of put into a bit of context, the amount of work that went into some of these figures. We had these Excalibur boards where this is just a version 3, where you can see there's a huge amount of variations and comments and all this kind of stuff going on. And this was version 4, and I think it went all the way up to version 5. But what we ended up with was these 6, I think, really beautiful results figures that do a really nice job of just showing how diverse Monty's capabilities are. And that's, I think what's so exciting about this is that any one of these would be an impressive result. But the fact that all of these capabilities kind of fall out almost automatically from developing sensorimotor AI informed by the cortex is pretty exciting, and feels like a pretty strong kind of signal that what we're doing is on the right track. And along the way, this resulted in 2 new repositories, which are providing comprehensive kind of support for anyone who wants to replicate these experiments. That's really important from the point of view of open science, and it should also really build trust in what we've done, and increase the likelihood that people kind of build off of this. But yeah, this was a huge amount of effort, when 30,000 lines of code and experiment configurations for the kind of main paper repository, and then this epic repository that Hojay put together, tbp.floppy, which for the first time enabled us to quantify the amount of flops that, the amount of compute essentially that Monty consumes, and enable us to benchmark that against VITs. But this doesn't capture all this other stuff, as Vivian was highlighting before. even just things like replicating the experiments, not to mention running them in the first place, and running them many times, I should say. Every time we'd realize some kind of change we should make to the figure, or some bug had been identified, or whatever it happened to be, that kind of led to a cascade of running all this again. So huge amount of effort. And so, just a quick kind of summary of some things in terms of new evaluations and metrics and things like that. We added better visualizations of movement sequences. For the first time, we properly quantified symmetry and kind of found a way of verifying that. We looked at adversarial color robustness. We looked at the kind of stepwise effects of the model-based policy. Looked at scaling of voting for the first time and figured out tie breaking. Quantified learning efficiency and also versus VIT. We had no comparisons before at all to deep learning architectures, and that was a huge effort, particularly on Hojie's effort to get that. Also comparing flops and quantifying that versus a VIT, also looking at continual learning and comparing that against the VIT. Plus, outside of that stuff, we got updated professional diagrams. We did a literature review on related approaches. Had a whole bunch of improvements to the configs, just simple things like specifying a voting system in Monty where you have multiple learning modules in a grid was not trivial at all before. Scott made lots of nice improvements to that. We have now kind of a comprehensive mathematical description of how Monty works, which we didn't have at all before, and notation for that. And then fixed a whole bunch of bugs, which, yeah, I said none of these were trivial. Things like when we started this, voting only worked with learning modules and sensor modules basically aligned in a one-dimensional grid or kind of line. We couldn't have kind of other arrangements. Something with the X% threshold we fixed, patch off object. That was again a huge effort on Scott's part. And then kind of semantic sensor. This was a thing that was sort of leaking into our experiments that we didn't want to. So I'm sure I've missed some stuff. So it was a lot of things, and of course, I think all these metrics and evaluations that we've now developed and the pipeline for visualizing them, all this stuff is work that we can reuse when Monty's capabilities grow, and we want to communicate that again. So it's definitely not kind of a one-off use case. And of course, now we have this 32-page paper that we can share with everyone and talk about when they ask, what can Monty actually do? So yeah, thanks everyone for their hard work.